Okay, so in example 4, we've got a random variable x, which is binomially distributed 40p. So remember, that means we've got 40 trials and p is the probability of success. So you don't need to write this out, but I like to write out what is our random variable x. So in this case, x is going to be the number of successes in 40 trials. And we know that x follows a binomial 40p. Now, a lot of the time in these questions, you won't get given that in the question, and I would recommend you writing that out because you often get a mark for it. And in this case, we've been given the hypotheses, but again, you won't always get given the hypotheses in the question, and you'll always get a mark for writing out what the hypotheses are. So in this exercise, I would recommend writing out the hypotheses each time so you get into the habit of doing it. This alternative hypothesis is a little bit different than we've seen in the previous examples. This is because this is called a two-tailed hypothesis. Notice that it's not p is less than 0.25 or p is greater than 0.25. We just want to try and find out what would suggest that p is different to 0.25. So this is what we call a two-tailed test. And you'll see why we call it a two-tailed test when we look at the distribution. So the next thing that we do in a hypothesis test is we say, well, if H0 is true, and the probability is 0.25, then x would be binomially distributed with 40 trials and the probability would be 0.25. Now it's useful at this point to work out what would you expect x to be. Well, if you've got 40 trials and the probability is 0.25, we'd expect x to be 10. So that means we would expect to have about 10 successes. So next we've got to try and work out what values of x are going to support H1, suggest that H1 is true. Well, encoded within this probability is not equal to 0.25, we've got two cases. Either the probability is less than 0.25 or the probability is greater than 0.25. If the probability of success is less than 0.25, then we would expect to get less than 10 successes because the probability of success is less than a quarter, so we'd expect to get less than 10. So that means that small values of x support H1. And by small, I mean significantly less than 10. And in this case, if the probability was greater than 0.25, then we'd expect to get significantly more than 10 successes. So large values of x support H1. And by large, I mean significantly more than 10. So next we need to work out what the critical region is. So we've got this 2% significance level. Now remember, that means that we can't have a probability of being in the critical region more than 2%. Now our critical region is going to be slightly different in this case because we want our critical region to include small values of x and large values of x. So what we need to do is we need to take this 2% significance level and we need to split it up into a left-hand tail and a right-hand tail. So let's do these separately and let's write that down. So what we do is we halve 2% and we're going to say, well, we want 1% in each tail. And we'll see what we mean by that in a second. So let's do the left tail critical region. So the left tail critical region is for the small values of x which support H1. So even though you can't draw the distribution in your exam, I think it's useful to try and look at the distribution to try and help us think about this. So along the horizontal axis here, I've got x, the number of successes, and on the vertical axis, I've got the probability of that number of successes. And this is all if H0 is true, so it's binomial 10, 0.25. And notice that 10 is the most likely number of successes, and the probability of getting 10 successes is just over 0.14. So we're doing our left critical region, so the small values of x, which are going to suggest that actually the probability is less than 0.25. So we've just got to do a bit of trial and error here. And if you didn't have the distribution in front of you, you would just have to try a value which seems significantly lower than what we'd expect, which is 10. So let's try x is less than or equal to 4, for example. Probability of x is less than or equal to 4. So we'll use our calculator to work that out. So you go to statistics, binomial, distribution, binomial, cumulative, and we're going to have 40 trials. The probability of success if H0 is true is 0.25, and we want the probability from 0 up to 4, the probability of x being less than or equal to 4. So on my calculator, I've got lower as 0, but you will just have x equals 4. You won't have upper equals 4, you'll have x equals 4. And that will give us the probability of x being less than or equal to 4, which is 1.60%. So let's go to our diagram here, and that means that if our critical region on the left tail, so the small values of x, was 4 or lower, then that probability would be 1.60%. So remember what we said here. We said that we want 1% in each tail, and normally we wouldn't be allowed to go over 1% in each tail, but this question is slightly different because it says we want it as close to 1% as possible. So what we need to do is we need to try making the critical region slightly smaller, see if we can get closer to 1%. So let's try x is less than or equal to 3. Let's try 3 or lower as our critical region to make it a bit smaller. So the probability of x being less than or equal to 3, use your calculator again, and you'd get that as 0.47%. So normally we would have to say that the critical region is x is less than or equal to 3 because we can't have a probability greater than 1% in each tail. But in this case, we've got to get as close to 1% as possible. Well, this is 0.6% away, and this is 0.53 away. So this is closest to 1%. So our critical region on the left-hand side is x is less than or equal to 3. So what that means is that if we have 3 or fewer successes, then we would reject H0 and say that the probability is not equal to 0.25. Let's do a similar thing for the right tail, critical region. So let's try the right tail. Again, we're just going to have to do a bit of trial and error. We know that we're going to have more than 10. We're going to have to see more than 10 successes to reject H0 and say that the probability is different. So let's try probability of x being greater or equal to 17. Okay, so to work out this probability, it's slightly more complicated because we're going to have to do 1 minus the probability of x being less than or equal to 16. So we'll go to our calculator and we'll put in cumulative binomial 16. And again, you won't have lower or 0, you'll just have x is 16. And that will give us the probability of x being less than or equal to 16. So that's going to be 1 minus 0.9884. And that will give us 1.16%. So that means that if our critical region was 17 or higher, so 17 or more, that would be 1.16%. So normally we wouldn't be allowed to have that, and we'd need to make our critical region a little bit smaller. So we would go to 18 or more and try and get that underneath 1%. So let's try probability of x being greater or equal to 18. To work that out, you'll need to do 1 minus the probability of x being less than or equal to 17. So that's 1 minus 0.9953, which is 0.47%. So normally we would have to go with x is greater than or equal to 18 for the right-hand critical region. But in this case, we want as close to 1% as possible. And actually, this x is greater than or equal to 17 is closest to 1%. So that means that our critical region is x is less than or equal to 3 or x is greater than or equal to 17. And that's far enough away from 10 to conclude that the probability of success is not equal to 0.25. And the intuition for this is basically, if you land in these critical regions, it's really, really unlikely that you land in this critical region. So you're going to conclude that actually the probability is probably either less than or greater than 0.25. So overall, our critical region is x is less than or equal to 3 or x is greater or equal to 17. Okay, and finally for part B, we need to write down what the significance level is. So remember, the actual significance level is what's the probability that you're in the critical region if H0 is true. So we've actually worked out these probabilities. So that's basically saying what's the probability that x is less than or equal to 3 or x is greater than or equal to 17 if H0 is true. And that's basically what's the probability of landing in this critical region if H0 is true. And that's a really small probability. So that's this probability plus this probability. So 0.47 plus 1.16. So that gives us an actual significance level of 1.63%. And notice that this is actually still less than the significance level that we were given in the question, which is 2%.